Hello and welcome back to the course on deep learning. Now that we know a bit more about LSTMs and how they work and what their architecture is like, today we're going to look at some practical applications, or specifically we're going to look at how LSTMs work inside practical applications. And it's going to be quite interesting and at the same time a bit magical, I would say. So let's get started. Here we've got the LSTM architecture. And we're going to be, to start off, we're going to be looking at this tangent function and how it fires up. So the images we're going to be using are all from Andrej Karpathy's blog. So thank you very much to Andrej for doing all of this amazing research. So you can see here, it's just incredible. So they've got some examples where they created some bogus linear algebra using trained up LSTMs, and then lots and lots of stuff. So here, these are the images we're going to be looking at just now, these ones as well. And there's lots of information here, lots of comments. So definitely check it out. We'll link to these at the end of the tutorial. This blog is called The Unreasonable Effectiveness of Recurrent Neural Networks. And the paper that Andrej published along with that, we'll also link to that paper as well. So basically, we're looking at this tangent function to start off with, and according to the paper, -1 means is going to be red, +1 is going to be blue. So let's get started. All right, so here's some text which was given to an RNN which learned to read text and kind of create text and predict what text is coming. And here, this is a snippet from the War and Peace, the huge novel by Tolstoy. And so here you can see that this neuron is activating, well, it is sensitive to, as it says here, sensitive to position in line. So you can see that when you get towards the end of the line, it's activating. And how does it know when it's the end of the line? Well, in this novel, you have about 80 symbols per line approximately. So it's counting how many symbols have passed. And that way it's trying to predict when the new line character is coming up, because the new line is just a character, right? It's an invisible character, and it's trying to predict where that character is going to appear. Then you got a cell that turns on inside quotes. Well, this says inside quotes. I think it's actually outside quotes, because here you see it says, "You mean to imply that I have nothing to eat out of. On the contrary, I can supply." So basically, somebody's talking and then say, warmly replied Shigagov. Shigagov, haven't read that in a long time. Who tried by every word. So basically, this is the inside the quotes, this is outside the quotes. I'm not sure if this is correct, but either case, one way or another, it's activating either inside the quotes or outside the quotes. And you can see, so this one is keeping track of what's happening. And so very similar to what we discussed previously, where we were keeping track of the subject, when that would help us understand if the subject is male or female, or we would be able to understand things like if it's a singular or plural, and that would affect our verbs in our translation. Similar thing. So it's important to know if you're inside or outside quotes, because that affects the rest of the text. And for instance, the easiest way you can think of that affects the text, that if you're inside the quotes, then there has to be another quote to close the quote. So you're anticipating another quote, something like that. Here's another one where what the input was the code of the Linux operating system, and here you can see that a cell activates inside if statement. So it's completely dormant everywhere else, but as soon as you have an if statement, it activates. If statement, it activates. If statement, it activates. So, and it is active. You can see it stops being active over here at the next at the actual body of the if statement. So it's only active for the main part, or for the condition of the if statement. And that can be important, because you are anticipating that the condition is going to close with a bracket, and then there's going to be a bracket curly brace to open up the body of the if statement. That's pretty cool. And then here you've got another one where this cell is sensitive to how deep you are inside of a nested expression. So as you go deeper and you get the expression gets more and more nested, this cell keeps track of that. So it's using this memory to keep track of it. And it's very important to remember that none of this is actually hard-coded into the neural network. All of this is learned by the network itself through thousands and thousands and thousands of iterations. It learns that, okay, I have this many hidden states, and out of them, I need to identify what's important in the text to keep track of. And it identifies, for instance, in this case, that understanding how deep you are inside a nested statement is important, and therefore it assigns one of its hidden states to keep track of that. So it has these resources, hidden states, or the memory cells, and it assigns them to keep track of certain things based on what it thinks is important. So it's really evolving like that on its own and deciding what's important, what's not, and how to allocate its resources to best complete the task. And I think that's very fascinating. And then here's an example of a cell that you can't really understand what it's doing. And according to Andrej Karpathy, about 95% of the cells are like this. They're doing something, but it's just not obvious to us what is happening. And it's like that example of CNNs where the filters or the features that we're looking out for, by the time they get to the last layer, they're completely unrecognizable to the human eye, but they make sense to the machine. Same thing here. So most of the time, 95% of the time, you can't really tell what's going on, but those 5% of the time, those were the examples we looked at, and they should be helpful to better understand what is kind of going on in the neural network when it's processing, for instance, text. So again, now we're back at our architecture. And now what we're going to be looking at is we're going to be looking at the actual output. So we're going to be looking at this value. So after it's gone through the tangent, the valve or the output gate, and now we're going to be looking at what's being produced over here. So here's an example again from Karpathy's or Andrej Karpathy's blog. And we're looking at a neural network that is reading. So this is a bit more detailed. So here it's not just showing us if it's active or not. You can see that you've got at the top if it's active or not every first line. And then in the other 5 lines, it is saying what the neural network is predicting that's going to happen next, what letter is going to come next, what symbol is going to come next. So you've got the combination of the two here. And just by looking at this, what do you think it's predicting? So I'm going to like outline the colors. Green means, for the top line, green means active, and blue means not active, and red means a very likely prediction, and light red means unlikely prediction. So let's talk about the top line. What do you think this specific hidden state in the neural network is looking out for? When do you think it's being activated? Well, I guess this one is pretty obvious. It's activating inside URLs. So here you can see that inside www, the hidden state is being activated, just like we saw in the previous examples, War and Peace and the Linux kernel. Here you can see that it's activated inside URLs, but now we have some additional stuff to look at. Now we can see what it's actually predicting that's going to be the next character. So for instance, under this W, you can see that it's predicting that the next character is going to be a W with the highest probability. And it's correct, it is a W. Then under this W, you can see that it's predicting another W, and it is correct. And then under this W, this is what the whole neural network is predicting. Under this W, what you're seeing is a dot, and that is correct. It is predicting a dot. So that's how it's gone up to here. And then after this dot, it thinks the next letter B will be a B, but it's actually a Y. But now knowing that it's a Y, it thinks it's going to be an A. Now knowing it's an A, it thinks it's going to be an N. And you can see that these are not as red as these because it's not sure about these predictions. And fair enough, it could be absolutely any website. Why would it be a B? It could be in any website, you can't tell. Maybe it could based on the context, but still it's very hard. But then when it gets to ynet new, N-E-W, it predicts an S with a very high likelihood. And it is indeed an S because it kind of knows that the word after you have new very likely you will have an S, or based on everything it's learned before, that in this particular type of text, it's news is mentioned quite often, because this is actually, as far as I understand, this is Wikipedia text. And then you have a dot, then after a dot, it predicts a C, it is a C. After a C, it predicts an O, it's an O. After an O, it predicts an M, it is an M. And then slash, it is a slash. So beautiful. So, and then it's done its job and it's not active anymore. And then this is what, but this is the neuron that we're looking at is not active anymore, but the neural network is still predicting things. So here you can see E, and then N, so it's incorrect. And then after the N, oh no, after the E, it's incorrect. After N, so after it has EN, it predicts a G, it's a G. And then it becomes more confident that it's the word English. Language, you can see that the predictions become more confident. So after the L, it didn't predict correctly, but after the LA, it's already predicting N, G, and so on, and so on, and so on. So it can actually predict the whole word based on just a few first letters. Websites, so on and so on. So you see that the actual neuron is still dormant. And then here you've got, again, off we go, www, it's predicting, and this one is getting activated. This one was pretty interesting because it goes CO, and then it predicts an M, but it's not an M, it's a dot. And it's like the neural network, the neural network is probably a bit upset at this stage, thinking, whoa, where's my M? And then it takes another shot. It says, okay, so probably U, because .co.uk, that's the UK website. But here, instead of a U, it's got an I and an L for Israel, .co.il, and therefore it kind of like didn't guess this time. But it's not even trying to guess. You can see it's not even trying to guess an I, because from what it's learned, .co.uk are much more likely to come up than .co.il. And we're not even looking at these other ones here, which you could look at them. They are, the second best guess, the third best guess, fourth and fifth, but you can see that they're not that red, and it will always put its highest likeliest guess at the top on the second line overall. So there we go. This is how to look at these pictures that Andrej has created. And for more, check out his blog, karpathy.github.io. There's a couple more of these examples there and more of the previous examples that we looked at. So hopefully this is helpful to show you what's going on inside the neural network when it's thinking and when it's processing information. In terms of references and additional reading, we've got the Andrej Karpathy blog, and we'll link to it in the resources for this course. This is the URL otherwise. And also we've got the Andrej Karpathy and others research paper, which was published in 2015. It's called Visualizing and Understanding Recurrent Networks. Very interesting read, actually, because if you're, there's not too much math and you can probably skip it, but even the insights parts and chapters, they're very interesting. They make you kind of feel that they say this in the paper, that they're like neuroscientists trying to understand what's going on. So they open up the brain of the neural network and monitor what's happening in one specific neuron or different neurons, and you actually feel from the language, the way that it's written, that it's as if they're exploring some alien, as if they're exploring some kind of extraterrestrial being and how it thinks. Because if you think about it, humans created these LSTMs and RNNs. These are just things that work on our computers. But because they are so advanced, because they involve so many different elements, so many different parts to them, and they're so complex, we now need to, after we've created them, now we need to study them as if they're separate beings, separate something that exists on its own. And it's just reading through it, kind of like, if you think of it that way, it gives you this mysterious feeling, or if you feel like it's something magical is happening, and at the same time you feel that few more years or maybe a decade from now, these things are going to be able to think completely on their own. So if you want to have some fun reading a research paper, this one's pretty cool, I think. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.